Inside pretty much every machine with moving parts, think your car's engine, massive industrial gears, you name it, there's this invisible hero at work: lubricant. For more than a century, that's been mineral oil. But as we all push for a more sustainable world, scientists are on this quest to create amazing high-performance lubricants from a source you might not expect: plants. And as they quickly found out, making an oil green is way, way harder than it sounds.
I mean, really think about that for a second. It's a huge question, right? With all the technology, all the engines, all the gears turning around us every single moment, what is the one thing that keeps all of it from just seizing up in a total catastrophic failure?
That's it. A film of lubricant so thin it's almost not there. Its whole job is to prevent direct metal-on-metal contact, which, as you can imagine, would lead to just a ton of friction, heat, and eventually total destruction. It's this invisible force that literally keeps our world in motion. But can we make it green?
And that gets us right to the heart of the problem that a team of researchers was facing back in 2011. See, it's one thing to make a lubricant that's biodegradable, but it's a whole other challenge to make one that can actually do its job and survive the insane pressures inside an engine. So, in the lab, everything looked perfect at first. The team successfully cooked up a bio-lubricant from plant-based stuff that had the perfect viscosity. That's the thickness to meet all the industry standards. But when they put it to the test, when it came to its most critical job, preventing parts from grinding each other into dust, it was a complete and total failure. So, what exactly is wear? Well, just picture rubbing two bricks together, right? All that dust that comes off, that's material being lost forever. The exact same thing happens, just on a microscopic level, with metal gears. Wear is the ultimate enemy, and a lubricant's #1 job is to stop it. Okay, so if you want to stop wear, you first have to be able to measure it. And to do that, scientists use this standardized method with a pretty awesome name: the 4-ball torture test. It's an experiment designed to put lubricants through, well, mechanical hell. And here is the machine that does all the torturing. Its design looks kind of simple, but its function is absolutely brutal. It's built to create a single point of extreme pressure and friction, which perfectly mimics the harshest conditions you'd find deep inside a real-world gearbox. So here's how this thing works. You take 3 steel balls, you lock them in place, then you pour in the lubricant you're testing. After that, you press a 4th ball down right on top of them and you spin it. And I mean spin it fast. We're talking 1,200 revolutions per minute heated up for a full hour. It's basically a pressure cooker for mechanical wear. After the test is done, you take out those bottom 3 balls and you look at them under a microscope. And this is what you see: a perfect circle, a wear scar. You could even call it a battle scar. The smaller and fainter this scar is, the better the lubricant did its job. The goal is super simple: make that scar as tiny as you possibly can. Now, our bio-lube? It failed this test. Badly. But the scientists weren't going to give up. They knew the base oil just needed some help. It needed a secret ingredient, an additive, to really boost its performance. So they staged a kind of showdown to find the perfect one. First things first, let's set the baseline. With no additives at all, the bio-lubricant left a huge wear scar of 0.840 millimeters. That's our starting point, and let me tell you, that is not good. The results of the showdown were just dramatic. The researchers tested a few different eco-friendly additives. One called benzotriazol, it helped a little. But another one, dibutyl phosphate, was the undisputed champion. It slashed the wear scar by more than half. Just look at that difference. 0.343 millimeters. That is a massive, massive improvement. So what was going on? Well, the dibutyl phosphite was doing something the base oil just couldn't do on its own. It was chemically bonding to the steel, creating this super tough protective layer. This was the breakthrough they were looking for. But okay, the big question: how does this new lab-made formula stack up against what you can actually buy on the shelf? Well, the researchers tested it against commercial synthetic gear oils, and the results were just stunning. Their bio-lube wasn't just as good, it was actually better than a lot of the established products. An amazing result. But the story isn't over yet. Because, of course, there was a twist. The very thing that made the additive so incredibly good at protecting against wear, well, it also created a new and potentially much more dangerous problem: a classic protection paradox. So, the next question they had to ask was this incredible anti-wear performance just too good to be true? Was there some kind of hidden cost to this powerful chemical reaction that was happening on the surface of the metal? To find out, they ran a corrosion test. It was pretty simple. They just soaked pieces of steel and copper in the different lubricant formulas at high temperatures to see what would happen. And the results for their winning formula with dibutyl phosphite, they were alarming. Instead of just protecting the steel, the additive was actually reacting with it, causing it to corrode. It was literally eating the metal away. So there it was. Their hero ingredient had a dark side. It was so reactive that while it stopped the steel from wearing down mechanically, it was slowly dissolving it chemically. And you just can't have an oil that destroys the very engine it's supposed to protect. The solution, it turned out, wasn't to find a new hero. It was to give their existing hero a sidekick. They needed to find a combination of additives that could work together as a team, with one covering the other's weaknesses. And they found the perfect partner in benzotriazol. That's the additive they had tested earlier. Remember? On its own, its wear protection was just okay. But it was a fantastic corrosion inhibitor. So you have the hero, dibutyl phosphite, providing the muscle against wear, and the sidekick, benzotriazol, providing the defensive shield against corrosion. Now, this was way trickier than it sounds. As the study itself points out, you can't just throw a bunch of additives into a bucket and hope for the best. A lot of times, they end up fighting each other for space on the metal surface, basically canceling each other out. So finding a pair that could actually work in harmony was a real chemical balancing act. And this final table, this tells the whole story. Dibutyl phosphite alone, great wear protection, but it's corrosive. Benzotriazole alone, it stops corrosion, but it's not great on wear. But the combination, the winning combo, it delivered an excellent wear scar and very low corrosion. It was truly the best of both worlds. So what started as this simple idea, let's make lubricant from plants, it led to this complex scientific journey of balancing protection and corrosion. And it just goes to show you that with the right chemistry, the future of what keeps our world running smoothly might not come from deep under the ground, but from what we can actually grow right on top of it. Makes you wonder, what other everyday products are ready for a green revolution?